Hi, everybody. I hope you're doing well. Well, we are getting close to the end of this semester and end of Math 100. Okay, so hopefully you've had a great semester, and we have this one more lesson, which is like half a lesson because there is no difference between the notes that you are going to take as you watch this video and the worksheet. Once you are finished with the notes, that piece of paper becomes your worksheet, which you will be scanning and uploading to the assignment called worksheet number 21. Okay, so this is a sort of a short lesson on one of those interesting political issues related to mathematics, and it's called gerrymandering. All right, so I'm going to start by showing you this picture, and then I'll go into the notes. So make sure you print out the notes for lesson 21, and then we'll get started, okay? All right, so because of the order in which we are covering this, we're doing this after the course project and right before the final exam. Lesson 21 is found right before the final exam module, between the course project module and the final exam module. And so this is where you can download the this is where you can download the worksheet number 21, which is the lesson notes. Right, and then of course this is the lesson 21 page where you have a link to this this video and so on. The answer key is here, but once you listen to and follow the lecture, then you will, by the end of this lesson, and as you take notes, you will have the sheet completed, which you will be turning into this. Okay, and there is no other separate homework or online worksheet for number 21. So there is no other online worksheet number 21. This is only the portal where you will be scanning and submitting your complete notes from lesson 21. All right, so what I wanted to show you at the beginning was, well, this is gerrymandering. What is gerrymandering? This is the Wikipedia page. And it is the practice intended to establish an unfair political advantage for a particular party or group by manipulating district boundaries, which is commonly used in first past the post-electoral systems. All right, so I'll explain and talk about this gerrymandering. But why is it called gerrymandering? Well, there is a politician by the name of Elbridge, and it's Gerry, but it's actually pronounced Gary, right? Except we don't call this gerrymandering, it's called gerrymandering just because of his spelling. But this is what he and people close to him came up with, right? Back in 1812. So this is not a recent practice, even though it's hotly debated during the recent years. But in Massachusetts, they divided the congressional district in a rather weird way. So what you're seeing is just one district, which consists of a bunch of these counties, right? And because of this weird, and by the way, this was done exactly for the purpose of favoring one of the political parties, okay? And so this is such a weird shaped congressional district. This is one congressional district, all right? And so they decided, look, this looks like a salamander. And so they call this practice Gerry's salamander, or it should be Gary, but it's called gerrymander. And so this is called gerrymandering. All right, so this is the reason for this sort of a strange name of the practice. Okay, but let's see what happens as we look at the notes, right? So get your notes for lesson number 21 and we'll start. All right, so here's an example of this, okay? Try to follow along. Suppose a county, okay, so we have this county consists of 6 regions or 6 areas shown below, right? And so this has 2 congressional districts. So your job is to divide this county into 2 congressional districts. All right, I'm going to circle 1, 2, 5, and 6 with red circles. So right now, these are red party dominated regions. Okay, now you can interpret red and blue however you want. I will refuse to call them and associate them with one particular party or others, but let's just assume we have a fictitious country where this county is located. And in this fictitious country, they have a red party and a blue party. Okay. I'm just going to consistently call them red and blue parties. All right. Now, you can see, and this is quite typical in the United States, but you have city areas, okay, and you have inner city areas that belong to or are dominated by a certain political party, and as you go into suburbs and rural areas, you have other party dominating. In this case, the red party. All right. As it says here, the urban neighborhoods, areas 3 and 4, are well, okay, so it's called Democrats dominated, and while the other areas are Republican dominated. So it seems like the red represents the Republicans and the blue the Democrats. All right, the numbers of registered voters in each area are as follows. So let's take a look at this. You have okay, so for instance, area 1, okay, you have 550 belonging to the red, and 500 belonging to the blue party, right? And altogether it's 1,500. But area 1 is dominated by the red party. And the same thing for area 2 and area 5 and area 6. But if you look at areas 3 and 4, you can see that there are more blue party registered voters than the red party registered voters. Okay, so your job is to draw the borders for congressional districts, but there are two restrictions. Okay, for instance, you can't choose this area, this area, this area, and this area, and call it one district. Why? Because districts are supposed to be connected. All right, and also you can have one tiny district and another big district. Okay, you have to each district should be able to represent about the same number of people. All right. So there are two restrictions. Okay. What are those restrictions? Well, in order to maintain equity and fairness, one district cannot be much bigger than the other ones. All right. So for instance, let's say for this type of population, for this county, let's suppose that, and it's not a definite number that's used in real life, but let's say for this particular scenario, each district must have at least 4,500 voters. Okay, so you can't have a district that consists of just 20 voters, for instance, okay, or 200 or 2,000. Each consists of, because you're only dividing this whole thing into two districts, okay, and by the way, the total number of voters in this entire county is 10,000. This is made so that it's easier for us to understand. And so 5,000 would be the average, right? And you can allow some difference. You don't have to make the division so that each congressional district is exactly 5,000. That's not possible many times. But 4,500 sounds like a reasonable amount. So let's say each of the two districts must have at least 4,500 voters. In addition, each district must be connected together. All right. So for instance, areas 2 and 3, where are 2 and 3? 2 is like here, 3 is over here. And so 2 and 3 together cannot be an independent congressional district. Okay, now if you have 2, 3, and 4, it's okay because that would be connected. But 2 and 3 alone cannot make up a district. Does it make sense? Okay, 1, 2, and 3 can, because 1, 2, and 3 would be connected. Okay, all right, so those are the two criteria, the rules we have to go by. All right, right now, currently, areas 1, 2, 5, and 6, those are all red party dominated areas. Okay, 1, 2, 5, 6. These are the suburbia and the agricultural rural areas. They belong to 1, 2, 5, and 6 belong to District A. And the urban, the inner city areas, which are 3 and 4, both Democrats dominated or both blue color dominated areas form District B. So we have District A and District B. Okay, verify that District A will elect a red party candidate and District B will elect a blue blue party candidate. And also verify that each district is big enough. Okay, so let's see. By the way, let me go ahead and draw these two districts in orange. So this is District A, okay? And this is District B. You get that right now, currently, those are the two districts. Okay, so District A belongs to the red party and District B belongs to the blue party. Let's make sure that this follows or this is in compliance with the two restrictions. The connectivity restriction is okay, right? Because A is connected together, B is connected together geographically, so that's fine. How about this 4,500 voter rule? Okay, let's go ahead and write down some numbers in here. In District 1, okay, so let's go ahead and I'm going to use a neutral color black here. Republican, how many Republicans are there in District 1? Okay, it says, I mean, red, okay. And then the blue party, you have 500, right? All right, and number 2, the area 2 has 600 and 510 blue party registered voters, and then 3 goes on this side because 3 and 4 belong to District B. 3 has 1,300 red party registered voters, 1,600 blue party blue party registered voters. 4, the city center has 1,080 red party registered voters and 1,320 blue party registered voters. Let's go to 5, rural east, that has 460 red and 380 blue. 6, the suburb south has 990 red and 710 blue. Okay, let's go ahead and add them up and see what kind of numbers we come up with. All right, so yeah, let's use a color that is neither blue or red so that we can stay neutral. Okay, so if you add up all of these numbers, it's 2,600 here. Okay, and then the blue colored, blue party registered voters in districts 1, 2, and 5, 6 add up to, just add up these numbers and you get 2,100. Okay, the sum of both is 4,700. Okay, so 4,700 registered voters are in District A. The sum here would be 2,380 and then 2,920. And the sum here is, of course, let's see, that's 5,300, right? Of course, I mean, 4,700 plus 5,300 would be, the total is 10,000 as expected. Okay, so you can see that the second criterion is, I guess the first criterion is also satisfied, right? Each district, District A has at least 4,500 voters and District B has at least 4,500 voters. So as far as the size is concerned, they are both fine. And as far as the connectivity is concerned, they are both fine. Now, if everybody votes as they register, you know, along the party line, so in District A, you clearly have 2,600 versus 2,100. So the red party wins. Okay, and so they will choose a red party politician to represent District A. Okay, now District B, of course, this has 2,920 is more than 2,380, so they will choose the blue party politician for their representative. Okay, so right now in this county that has 2 congressional districts, you have 1 blue party representative and 1 red party representative. Okay, clear about that? All right, great. All right, so now number 2, someone proposed that areas 1, 3, and 6 form District A and 2, 4, and 5 form District B. Okay, now what, and somebody said, no, you can't do that. All right, let's see why this is not allowed. 1, 3, and 6. And I'll go ahead and erase this now. All right, give me a second. Okay, so someone suggested 1, 3, and 6 form District A, and 2, 4, and 5 form District B. Now they're both connected, so connectivity is okay, right? What's wrong with that? And maybe somebody's trying to manipulate the votes or whatever, okay? And that is a new and a redrawing of the congressional district. And according to this rule, it seems like somebody's saying no, you can't do that. Right? Let's see why. So if you look at 1, 3, and 6, okay, well, actually, let's look at the District B or the proposed District B. 2, 4, and 5. So all you have to do is just add up the numbers in 2, 4, and 5. So the area 2, 4, and 5, areas 2, 4, and 5 would have, and I have the numbers here, it's 11,100 plus 2,400 plus 840, right? These are the numbers you see. Whoops, that's not 245, right? So sorry about that. 245 is not here. 2 is here, and then 4 is here, and 5 is here. So 1110 plus 2400 plus 840. If you add these numbers up here, you get 4,340 registered voters in area B or District B. How many do you have to have in each district? 4,500 voters, okay? So this redrawing plan would be called violation or not non-compliant, and so you can't do it this way. All right, so this, too bad, it's not going to work. All right, so that's why again you want to make sure that each congressional district is about the same size in terms of the population, or in this case the registered voters numbers, and so that would not be allowed. All right, so this is too small. One district, namely District B, is too small, and of course the other one would be too large. Okay. All right, number 3. Someone else proposed that areas 1, 2, and 4 and 5 form District A, and 3 and 6 District B. Verify that each district is big enough, and of course each district has to be connected, and see what happens to the winners. Okay, so in this case you are asked to do this 1, 2, 4, and 5. So where are 1, 2, 4, and 5? 1, 2, 4, and 5 will be this district, and this is what is proposed as new District A, and 3 and 6 would be District B. All right, so that is a proposal under consideration, and so let's see what happens to the numbers. Okay, so use all of these numbers you have here, okay, and then go ahead and fill this out. And you may want to do this right now, and click pause, and when you think you have got the right numbers, you can come back to verify your numbers. All right, so for so 1, 2, and 3, 4, these going here, and areas 3 and 6 going here. Okay, so in District A, or the new proposed District A, area 1 has 550 red party registered voters and 500 blue registered voters. 2 has 600. Of course, these are the same numbers you see here. Right. The only difference is you don't have 5 here anymore, right? You have 4. Sorry, you have 5, but not 6. 6 go over here, right? So it's 600, 510, and then 4, it's 1,080. I'm actually looking here, right? And then this is 1320, and 5 is already here, 460 and 380. All right. So again, I'm just writing down these numbers again. 3 has 1,300 red and 1,600 blue, and number 6 is 990 red and 710 blue. All right, let's add them up. If you add up these 4 numbers here, you get 2690, and that's for the red party registered voters. And for the blue party registered voters in the new proposed District A, if you add up these numbers here, you get 2710. In District B, you add up these 2 numbers and you get 2290, and here the sum will be 2310. Okay, so before you you figure out who wins in what district. Let's make sure that this is within the allowed number of registered voters. If you add up these numbers here, you get 5,400. The other one would be 4,600. Okay, now remember, the rule is that every the district has to have at least 4,500 voters. So this is okay and this is okay, right? And each district is connected, as you saw in the picture here. A is connected together and B is connected together. So this will be a legitimate, legal, and compliant way of redrawing districts. There's nothing wrong with it. Okay, now let's see what happens to the winners. So if you compare these two numbers, of course, you can see that it's a very close call, but if every registered voter votes according to his or her political affiliation, there would be blue who would be the winner of District A by 20 votes. Okay, really close. You would not call this a landslide, but blue would win, right? And over here, 2290 and 2310, again by the difference of 20 votes. Right? In District B, they will choose the blue party politician to represent District B. This is exactly what we were talking about. So they will, whoever came up with this idea probably belongs to or likes the idea that the blue party should dominate, because by redrawing, you notice here originally the districts were um, let's see, suppose a county, right? So you have um, currently areas 1, 2, 5, and 6. 1, 2, 5, and 6 had a red party representative, and 3 and 4, the second district, had a blue party representative. But by redrawing the districts, guess what? Now, because of this manipulative procedure, or because of the redrawing, a careful redrawing, in both of these districts, they will choose the blue party candidate for their representatives, right? So this is, you can say it's creative and intelligent, or you can say this is manipulative and not a good way to do it. And it may depend on which party you like, all right? But this is what happens in mathematics. And of course, in this case, it turns out the redrawing favored the blue color party. But of course, it could be done in favor of the other party as well. And in fact, this is not drawn by hand. Okay, they have a very sophisticated software, computer programs that would do all kinds of possibilities to figure out, how, as one follows all of these requirements, like the connectivity criteria and the number of registered voters in each, the minimum number in each district, by following all the rules, okay, you still have lots of freedom. And in what different ways can you redraw so that one party would be favored? That's the kind of thing that is done all the time. And in some states, this practice is considered illegal. It's really hard to figure out what is legal and what is not, okay? But that's for the courts to decide. But I do want you to know this is a practice called gerrymandering, and it is frequently done in our democratic society. Okay, so that's it. This was the last lesson, all right? And as I said before, don't be looking for any online worksheet, all right? All you have to do at this point, listen carefully, is to, you should have the form filled out, the notes/worksheet 21 filled out already if you followed along the video lesson, all right? And you have all those numbers filling the boxes, all right? That's what you should scan and go to the portal in the module called lesson number 21 or worksheet 21, all right? And you scan your notes and upload it, and I will give you credit. It's going to be 1 point for the worksheet, but that's what you would do. Okay, and so I hope you've learned something, maybe some small thing about, about political science, but it's based on mathematics, and math can be used or abused in politics as well. All right, so with that, until I see you next, I hope you have a great week. I'll talk to you later. Bye.